lesson on stoichiometry. Before we learn how to do stoichiometric equations, we must first learn the definitions and what stoichiometry means. The definition of stoichiometry, in complex terms, is the relationship between the relative qualities of substances taking part in a reaction or forming a compound, typically a ratio of whole numbers. But in simpler terms, stoichiometry is the determination of how much stuff you can make in a reaction from some given amount of reactant. For stoichiometric equations, this is what it looks like. You have mass A, or molecules A, and you would have to convert that into moles A. Then, using a mole ratio, you would convert that number into moles B. And then once you have that number, you would convert that number into moles B, or molecules B. Think of it like this. Making s'mores. We all know how to do that, right? It calls for a recipe, and the recipe is graham crackers plus marshmallows plus chocolate will give you your s'more. But to make a s'more, you would have to have at least 2 pieces of graham crackers. If you have any less, if you only have 1, you cannot make a s'more. This will be discussed in a further lesson. So now, we will learn how to do stoichiometry in its most basic form.
So first, I will show you an ideal stoichiometry problem. Here we have the equation, hydrogen gas and bromine gas reacting to form hydrobromic acid. Now the first step in solving a stoichiometric equation is to balance the equation. So we're going to take the reactants and the products and set them up in an easy to read grid, just like this. Now we're going to take the number of hydrogen atoms on the reactant side, which is 2, and put them under the reactants column. The same goes with bromine. After that, we'll move to the product side, where we have 1 hydrogen and 1 bromine. Now we need to balance it. The easiest way is to just guess and check, just like this. 2 bromines, that makes this 2 hydrogens, and our balanced equation will be as follows. Now we have 1 mole of hydrogen gas and 1 mole of bromine gas reacting to form 2 moles of hydrobromic acid. Now once we have the equation balanced, we can move on to our final calculations. Now here, we want to calculate the amount of hydrobromic acid produced from 1.5 grams of hydrogen gas. Now we'll start by calculating the molar masses of both hydrogen gas and hydrobromic acid. So we'll take hydrogen gas and the molar mass, which is 1.008 grams, multiply that by the amount of hydrogen atoms we have. This will equal 2.016 grams of hydrogen gas total. Next, we'll take hydrobromic acid, where we have 1 hydrogen atom times 1.008 grams, and 1 bromine atom times 79.904 grams. After we have those products, we add them together and we get 80.912 grams. Now what you have to be careful of when you do these molar mass equations are the sig figs involved. After you have the products, if there are only 3 sig figs here where this cuts off, then you have to make sure you have the same amount of sig figs to the place of the lowest amount. Now after you have the molar masses, move on to the final calculation. Now we have 1.5 grams of hydrogen in the reaction. You need to convert that to moles of hydrogen. So we have 2.016 grams of hydrogen in 1 mole of hydrogen gas. Now we need to convert moles of hydrogen gas to moles of hydrobromic acid. Now it takes 1 mole of hydrogen gas to produce 2 moles of hydrobromic acid. Once you've done that, you convert the moles of hydrobromic acid to the grams of hydrobromic acid, which is 80.912 grams. After you've completed this setup, you simply multiply and divide according to the numbers in the chart. The answer you come out with is 120 grams of hydrobromic acid. Now, you have to make sure you keep your sig figs in line, as we have here, 2 sig figs from the hydrogen gas. And yes, our answer is 120 grams of hydrobromic acid. This is a simple stoichiometric equation. Now we'll show you more complex equations.
All right. Now in this problem, instead of being given only one amount of our reactants, we now have 2. So in this equation, zinc sulfide plus hydrochloric acid reacts to form zinc chloride and hydrosulfuric acid. So the problem states that 22 grams of zinc sulfide react with 7 grams of hydrochloric acid. Determine the limiting reactant, the amount of zinc chloride produced, the excess reactant, and how much of the excess reactant is left after this reaction. So, first, before we even get started with that, we have to balance this equation. So, we will make a table, just as in the previous problem. So we have zinc, sulfur, hydrogen, and chlorine. On the reactant side, we have 1 of each element. Now on the products, it is similar to that, except we have 2 hydrogen, 2 chlorine. So, to correct that, we will put 2 moles of hydrochloric acid to make it balanced. So, now that we have our balanced equation, we can start with this problem. So the way to approach this problem is to divide it into 2 stoichiometry problems. So we will do one with 22 grams of zinc sulfide, and then one with 7 grams of hydrochloric acid. So, just like in the other one, we will start with our amount, so 22.0 grams of zinc sulfide. Now we need to convert this to moles. So to do that, we will have to calculate our molar mass of zinc sulfide. So we have 1 zinc and 1 sulfur. Sulfur molar mass is 32.06 grams. And for zinc, its molar mass is 65 0.39 grams. So since we only have one of each, we can add these up right here, and we will get 97.45 grams. So we'll put that down here. This is equal to 1 mole of zinc sulfide. Now, we'll use the mole ratio to convert this into zinc chloride. So we have 1 mole of zinc sulfide reacting to make 1 mole of zinc chloride. Now, we have to convert moles of zinc chloride to grams. So, again, we have to calculate the molar mass of zinc chloride. So to do that, we have 1 zinc and 2 chlorides. Zinc, as we know, is 65.39 grams, and chlorine is 35.453 grams. So this will give us 65.39 grams, and then we'll add that to 2 times 35.453, which is 70.906. And now, because of sig figs, we have to line them up by place value when we're adding. So in this case, it goes to the hundredths. So we will cut it off, this point here, and now we will add them up to get 136.29 grams. So, back to the problem. 1 mole of zinc chloride is equal to 136.29 grams of zinc chloride. Now, we will do all of that, and you will get 31.6 grams of zinc chloride. Now what we have to do is we have to figure out how many grams of zinc chloride we will get with 7 grams of hydrochloric acid. So we will do the exact same thing as we have done here, except with 7.00 grams of hydrochloric acid. So, as the same as above, we'll calculate the molar mass of hydrochloric acid. So it will be 1 hydrogen times 1.008, which is its molar mass, and then 1 chloride, which, as we have figured out earlier, is 35.453. So when we add this up, we will get 36.461. So we will put that down here. So 36.461 grams of hydrochloric acid will give you 1 mole of hydrochloric acid. So now we have to convert this using the molar mass ratio. So in our equation above, we have 2 moles of hydrochloric acid will produce 1 mole of zinc chloride. So on the bottom here, we will have 2 moles of hydrochloric acid. We grant you 1 mole of zinc chloride. Now we need to convert the moles of zinc chloride to grams. So we have figured out a value above. So we will just repeat that. So we have 1 mole of zinc chloride is equivalent to 136.29 grams of zinc chloride. Now, after calculating all of this, you will end up with 13.1 grams of zinc chloride. This is because, so matching with sig figs, you have 3 sig figs at the start, and here you have 3 sig figs at the end. So, based on these calculations, to find the limiting reactant is the element or compound that gave you the least amount of your product, because the limiting reactant limits what you get for your product. So in this case, hydrochloric acid is the limiting reactant. And the amount that it produced was 13.1 grams of zinc chloride. So now the rest of the question says, what is the excess reactant? So if hydrochloric acid is the limiting reactant, then by process of elimination, zinc sulfide is the excess reactant. So now it says, how do you calculate the amount of your excess reactant? So as we don't have enough space, let's go on to another sheet. And so to calculate the amount of excess reactant you have, it is the amount of your excess minus the amount of your excess multiplied by the amount produced using your limiting reactant over the amount theoretically produced, which is with your excess, because that amount can't actually be produced. It is only theoretical according to stoichiometry. So we will plug in our values. So the amount of our excess, as at the start, was 22.0 grams of zinc sulfide minus 22.0 grams of zinc sulfide multiplied by 13.1 grams, which is the amount produced by our limiting reactant, over the amount produced by our excess reactant, which was 31.6 grams. So, as a result, the amount of your excess reactant is 14.9 grams of zinc sulfide. So, in this case, sig figs match, because we're subtracting, we have to go to the place value that these numbers go to, which is the 10th place, which is expressed in our final answer. So this is how you do limiting reactant problems. Now we will go on to percent yield.
So we have nitrogen plus hydrogen equals ammonia. And our question here is, calculate the amount of ammonia produced if you had 15.0 grams of nitrogen. What you would do here is, as always, balance the equation first, as such. You have 2 nitrogen here, and 2 hydrogen on that side, and your product has 1 nitrogen and 3 hydrogen. To balance it, you would do such to get 2 nitrogen on both sides, and this would be 6 because you're multiplying the entire equation by 2. Then you need to place a 3 behind the hydrogen to make the equation balanced. So now we get to calculating the amount of ammonia if I had 15.0 grams of nitrogen. So we have this amount right here, 15.0 grams of nitrogen. And you would need to find how many grams of nitrogen are in 1 mole of nitrogen. So to find that, since you have 2 nitrogen, we do it as such. And the amount of nitrogen we have is 2 times 14.007 grams to get 28.014 grams of nitrogen. And you also have, oh, that's it. Nitrogen's all they ask for. So, in 1 mole of nitrogen, you have 28.014 grams of nitrogen as well. Now, you have eliminated the grams unit on these 2 sides. But now, since the question calls for the amount of ammonia, the answer would be in grams. So you would have to convert moles of nitrogen into moles of ammonia. And how you would do so is, since you have 1 mole of nitrogen and 2 moles of ammonia in your equation, that's how you would set it up. And in 1 mole of ammonia, you would have and 3 times H times 1.008 grams. This would equal 14.007 and 3.024 grams. And if you add that up, it would equal 17.031 grams. And you plug that number right in here. Yep, and this would give you 18.2 grams of ammonia. Normally, this answer would be much longer with plenty of other numbers, and it would just go on and on, like 18.27789 a billion. But since the lowest amount of sig figs we have here is 15.0 grams, your answer should only have 18.2 grams, 18.2 sig, should only have 3 sig figs as well to match up with the 3 sig figs found here. So your answer would be 18.2 grams of ammonia. But remember, we're calculating for percent yield here. So this number will play a factor, but it's not the only thing that matters right now. So if the reaction produced 15.0 grams of ammonia, what is the percent yield? So 15.0 is the actual amount of ammonia produced. But in our previous equation, we got 18.2 grams of ammonia. But remember, this isn't the actuality. Like in normal terms, we could have some percent error and less of a product can be produced. So in actuality, only 15.0 grams of ammonia were produced. So to find the percent yield, you would do as such. 15 grams over 18.2 grams times 100, because this is percent, to give you a percent yield of 83%. So your percent yield is 83% ammonia. Yep. So using all of your knowledge learned so far, You can now use stoichiometric equations, balance them, solve for percent yield, regular stoichiometric equations, and limiting reactant. Congratulations. You have successfully learned stoichiometric equations, science.